All right, so which ones in the homework do you want to talk about? All of them. We don't have to, can't say all of them.
Number 7.
7?
What is S? That's what I'm trying to figure out.
Nothing. Just a term. Okay, so we'll do it.
Yeah, but figure out what
7? This one? Something like that?
Yeah. Give us the submission. It's impossible.
It's not impossible.
It's very close.
No.
I was like, wow, this would have been an easy one going over in class. I did the homework, and it's like pretty right out.
So that's the thing. Is like in class, we are learning concepts, right? Okay. And then when we get to our homework, we should be then applying those concepts. And maybe not directly the same types of questions, but the same procedure, same idea. So what we got here? We've got something that if I were to distribute that n up top, you'd have something n squared, right? That'd be your largest power, would be power of 2, right? So then you should be able to maybe go through your factoring tool, okay? GCF, product sum, AC method, and then you're going to find out eventually you're going to get down to quadratic formula, and that's the route you want to go on this, okay? But there's some preliminary work that has to be done. So that preliminary work should be to take both sides and get rid of that fraction, right? So is that going to give me 9s? So 9s is equal to, now I'm just going to go ahead and, maybe we'll be deliberate here, n times n plus 1, right? So does that now turn into 9s equal n squared plus n? Go ahead and distribute that n, right? Okay. So it's quadratic. So if it's quadratic, what do I get it equal to? 0. So I'm going to have 0 equals n squared plus n minus 9s. Okay, now here's the thing. You ask, what does the s mean? Well, the s is a variable term. So we don't know what s is, but if it was 1, wouldn't my c term just be negative 9? If it was 2, wouldn't my c term be negative 18? Okay, so if it was 12, it'd be 108, right? Negative 108. Okay? So whatever s is going to make that c term a constant, right? Now, because you don't know what it is, you can't really do the AC method here or the sum and product technique here. Two numbers that multiply together give me 9s and add to give me 1. Because I don't know what s is, right? That's different depending on what s is. So those procedures aren't going to work. But what always works? Quadratic formula. Okay? So when I do the quadratic formula, okay, this 1 out in front is my a, right? This 1 here is my b, and then negative 9s. Remember, depending on what s is, that will change, but that's my c. Okay? So then, plugging that stuff into the quadratic formula, we're looking at n. Okay, so when we use the quadratic formula, you always are solving for your variable terms. My variable term here is n. So I go n is equal to opposite of b. But in regards to ax squared plus bx plus c equals 0, if I use the quadratic formula here, it would be x is equal to quadratic formula, right? So what we're doing is we're saying, well, it's a n squared plus bn plus c. C is just equivalent to 9s. So still the variable term for the quadratic is n in this case. Does that make sense? Okay. So quadratic formula opposite of b, so negative 1 plus or minus b squared, which would be 1, right? minus 4a times c is now 9s. All over 2 times a, which is just that one. All right, let's go ahead and...
Part of the interruption, but with all sophomores, last names A through F, please report to the auditorium lobby for pictures. Again, that is sophomores, last names A through F. Thank you.
Okay, so I've got, in this discriminant, I've got 1 minus 4 times 1 times negative 9s. What does that negative 4 times 1 times negative 9s turn into? What's 4 times 9? 36, right? They're both negative, so it's positive. And then I've got the s that goes along. All over 2. Okay? Now, that is your answer. However, WebAssign does not have a button for plus or minus. So you guys type in -1 plus 1 plus 36s all over 2. And then you've got to do -1 minus 1 plus 36s all over 2. Okay? Now, those of you that have gotten this wrong, you don't see that as the feedback they give you, right? The feedback they give you looks nothing like that. Let me kind of display that. That's the feedback they give you. That looks nothing like what I had written. Okay? However, going through a little bit of algebra, we can generate that. So let's just deal with this first one here. Okay? Since you have a sum up top and a singular denominator, that means you can pull that apart into 2 fractions with the same denominator. You can rewrite this as n is equal to -1 over 2 plus 1 plus 36s under my radical all over 2. Does that make sense? That still looks nothing like what they had, because they had a 1/2 out front, right? Or -1/2. Well, can I factor a 1/2 out of this term and out of that term? Yeah, I'll take out a -1/2. So that's going to turn this into, actually, what did they factor out? They factor out a 1/2 or -1/2?
Wait, so
They factor out a 1/2.
we put the first answer that we got, did it right?
Yes. But I'm trying to show you what happens when you answer it wrong several times, and it gives you feedback. And a lot of people have been saying, well, I have no idea how to get to that. So I can factor out a 1/2, and that's going to leave me then inside here a -1, okay, plus then root 1 plus 36s. And then what they do, for some reason, is that they take this 1/2, and now they like to write the root first, 1 plus 36s, and they put the -1 back here at the end. I don't like doing that because by hand sometimes we forget whether that -1 should be underneath or not. It should not be in this case. And that then is the feedback they give you. Does that make sense to everybody? So as we go through the year, and it's going to happen from time to time, there's a huge catalog of equivalent results in the background of WebAssign that are going to judge whether you've gotten it right or wrong. Okay? That is one of them. That's the one that they display. Now, if you would have typed in the orange ones up there, like Blaze was asking, if you would have typed these 2 orange ones in right here, absolutely it gives you credit for it. Okay? Does that kind of make sense? So at any time throughout the year, guys, if you think you're doing something right, well, obviously it's counting it wrong, just let me know, okay? And we can look at the different formats, and that might be the issue. Because I'm seeing a lot of people come to me, I can't get that black phrase. I don't know how to do that. Okay? We don't need to get there. The issue you're having is probably arithmetic, okay? And not so much structure, okay? So the structures that they give you in feedback might not always be the structure that we learn in class or we've come accustomed to. So just keep that in mind. Does that help?
No, I just got it wrong.
that what you typed in?
So just like this.
Is this your word?
Bro, this is hard.
Well, it's because when you have it this way, so this whole numerator is over 2.
Okay.
So if you extend that to get this -1 up in that numerator, you'll be fine. Other questions on there that you guys want to discuss?
Hey, can we go over like 9? I know that seems like too good to go over, but.
Yeah. Okay, so this question is going to maybe be something that we talk about today, provided the time. It says a rectangular garden is 9 feet longer than it is wide. Okay. Now you guys did these last year. These are like optimization type problems. Okay, if you've heard that word before. Okay, a rectangular garden is 9 feet longer than it is wide. Its area is 400 square feet. What are its dimensions? Okay. I think the best thing here, guys, is draw a picture. Okay, so I'm going to draw my rectangle. Okay, it's 9 feet longer than it is wide. Do you know what its width is? No, so I'm going to let the width be W. So now what's its length going to be? W plus 9. Okay, area is 400 square feet. How do I find area of a rectangle? Length times width, right? Well, right now, we know our length is W plus 9, and we know our width is W, correct? And we know capital A is 400. Does that give me that? So now I'm going to go W squared plus 9W minus 400 is equal to 0.
Pardon the interruption, but would all sophomores' last names G through P now report to the auditorium lobby for pictures? Again, all sophomores' last names G through P. Thank you.
All right, so do we have any factors that multiply? You got to give me 400, negative 400, add give me 9. Anything off the top of your head? $25.16. Okay, so we've got W. Now it's got to be what? Plus 25. W minus 16. Okay, so W plus 25 equals 0. W minus 16 equals 0. So W equals negative 25, right? Or W equals 16. Which one of those does not work? Yeah, you can't have a distance that's negative. So the width can't be negative 25. However, what you find out here in a moment is that if W is 16, what is the length? It is indeed 25, right? So that's what it's looking for, those two dimensions, 25 and 16. Not the only way you can do it, all right? We wrote this in terms of the width. Should I do this? Okay, now it says a rectangular garden is 9 feet longer than it is wide. Let's say I don't know what the length is. So I call that L. Could I call this L minus 9? Is L still 9 more than the width? Does that make sense to everybody? So I could rewrite this as 400 is equal to L squared minus 9L. L squared minus 9L minus 400 is equal to 0. Factor that, I get L. It's going to be the same two factors, but now the 25 is negative, the 16 is positive. So it's going to give me L to be 25 or L to be negative 16. Now you see that that's got to be 25, and then that would be the 16. Does that make sense? I think a lot of people will use the one on the left, but I think maybe you were taught that when you read an expression, an equation, phrase that talks about objects like length and width, you let your simplest variable be the thing you know the least amount of information about, right? We know the least, from that phrase, we know the least about the width. So that's our variable BW. Any others? $12? Okay. All right, so number 12, so this is 1.4, number 12. All right, so it says 2 fishing boats depart a harbor at the same time, one traveling east, the other traveling south. So that's nice because they're traveling, if one's traveling east, one's traveling south, they're 90 degrees from one another, right? That's their angle of departure. It says the eastbound boat travels, did I cut it off? Apologize. The eastbound travels at a speed of 7 miles per hour. Let me zoom out. Faster. Okay. And I'm just not accustomed to it right now, but the Zoom features on these programs that I use throughout the day are a little bit different, so sometimes I obviously mess up. I know it's kind of hard to see, but it says 2 fishing boats depart a harbor at the same time, one traveling east, the other south, okay? So that gave us that picture that here's the one going south, and then we'll get the one going east. Okay, so that's a 90-degree angle between them, right? It says the eastbound boat travels at a speed 7 miles per hour faster than the southbound boat. So do you know how fast the southbound boat is going? No. So let's just let that be, I'm going to use R for rate. So then isn't the eastbound, it's going 7 miles faster. So the eastbound should be R plus 7, right? Because after 7 hours, the boats are 91 miles apart. 91 miles apart. So, doesn't it that's terrible. What in the world? There we go. Doesn't that line there represent 91 miles? Yeah. Okay. Now here's where we got to be careful. These were rates, and this is a distance. Okay? So we can't equate them. Does that make sense? All right, there is a relationship here. What kind of triangle do I have?
Right.
A right triangle. What is the number one theorem that we've memorized since like the 5th grade with right triangles? Pythagorean theorem. A squared plus B squared equals C squared. Okay? But that's in terms of distances, correct?
Yeah.
Right now we've got rates up there. But it says, how long have I been traveling? 7 hours. You should be able to go up to, you got to turn flash on. Doesn't distance So this here is a distance. That's a rate. That's a rate. Doesn't distance, though, equal rate times time? Does that make sense? What was our time traveling? 7 hours. So can't I change this to a distance by multiplying by 7? Can't I change this to a distance by multiplying by 7?
I don't remember.
Okay. So I get 7R, and this is what? 7R plus 49, and this is 91. So now I should be, and then now they're all distances, right? Okay. So I'm going to go 7R squared plus 7R plus 49 squared equals 91 squared. Might be, let me see here real quick. I think it's perfectly legitimate quadratic, so we get, kind of multiplying this stuff out real quick. 49R squared plus then that's going to be 49R squared. Then we've got to figure out what our middle term is going to be. So that's going to be 49 times 7 times 2, 686. R plus then now we're going to take 49 squared, which is 2401. And then we'll take 91 squared. 8281. And that's fine. You can do all that stuff. I mean, 98R squared plus 686R. Now I'm going to take 2401, subtract from it 8281.
I looked down for a second and I'm lost. Where'd you get the
Square that. Square the first term gives you 49R squared, right? Square the back term gives me 2401. Multiply 7R and 49. Gives me 343, and then I double it.
What did you square to get the 2401? 49.
49.
Wait, what did you square to get?
So 7R plus 49 squared means this, right? Means 7R plus 49 times 7R plus 49. If I FOIL that, that's what I get.
Oh, so you have, I forgot you had to do it that way.
Okay, so the 686 is the O and I of that. Now, if I look at this, I hope the 686, does that divide by 98? Yes, it does. Does 580 or 5880 divide by 98? Yes, it does. So this makes it a lot easier, but divided by 98, I get R squared plus 7R minus then, I think that was 60. Hello? Yeah. It doesn't. Wildcat 1 is fine, something like that. It doesn't matter. I think it was Beaver 55. I don't think so. I don't know. I thought. I usually don't. Okay. All right. Okay. Thank you. Bye. All right. So does that then factor easily? 12 and 5, right?
Pardon the interruption, but with sophomores last names Q through Z, please report to the auditorium lobby at this time for pictures. Again, all sophomores, last names Q through Z. Thank you.
You just forget about whatever you take out, like it doesn't matter anymore.
Yeah, okay, so that's the thing, 'cause sometimes it matters, sometimes it doesn't, because it's an equation, I can divide that by 98, that by 98, that by 98, and I'm actually dividing that by 98 as well. So because I'm dividing the whole thing by 98, the 98 can vanish. Okay? Now when I do that, can a rate be negative 12? No. Okay? Now I like solving it that way because it solves for R, which we said was a rate, and that's the question to find the speed of the southbound boat. Okay? Well, the southbound boat we said was just R, correct? So in this case it'd be 5 miles per hour. Okay? There are other ways of doing this if you want to alleviate some of this algebra. The way we could do it, alleviating the algebra, but we got to pay attention to what our answer looks like then, okay, is that we can leave this as R, that as R plus 7. Those are rates, and this is 91, which is a distance. Well, we know that distance is equal to rate times time, right? If I take my distance divided by time, does that give me a rate? Can I divide that by 7 hours and get a rate of 13? Does that make sense? Is that okay with everybody? So now it might be easier to say, well, R squared plus then R plus 7 squared is equal to 13 squared. So it gives me R squared plus now R squared plus 14R plus 49 is equal to 169. Gives me 2R squareds, a 14R, minus 120. Divide everything by 2. R squared plus 7R minus 60. Does that end up being the same thing as that? You just gotta make sure that you pay attention to the components that they're giving you for the picture. They have to relate to one another. Okay? If I'm going to use A squared plus B squared equals C squared, they all need to be the same type of object. They all need to be rates, or they all need to be distances, and then kind of mess around with it that way. Is that okay?
Yeah.
Could I use quadratic formula there? I can always use quadratic formula, right? Any others on there you guys are worried about? 13 through 16. Okay. That's part of today's notes. Part of today's notes. So here, all we're trying to do here is solve for R, right? Okay, what will always work solving for R? Quadratic formula, so that might be an approach there for that one. Okay, get everything equal to 0 first. This one here, okay, you don't like those denominators, right? Let's pull this one out. This one's 16. All right, so we talked about some of these equations. So this is where we've got to think about what we've already done. Remember, when we talked about linear equation things, we had some equations like this, and we had to multiply by the LCD, right?
Yep.
Okay. So if I'm going to multiply by the LCD, R squared needs to be part of my LCD. Okay. Now when I choose R squared, does R already get incorporated in? And then I've got to multiply by 1 minus R. So that's my LCD. I'm going to multiply every single thing by that. So now when I do that, okay, so that R is going to cancel with one of these, right? And it leaves me r times 1 minus r times that 1, which is just r times 1 minus r, right? Multiply here. Oh, this should be a 1. That's a minus 1. Minus 1. So I'm going to take that, and that's going to cancel with that, right? And leaves me plus 6 times r squared. And now the r squared here going to cancel out. It's going to be 12 times 1 minus r. Does that get rid of all your fractions? And now it's just a matter of rewriting this as r minus r squared plus 6r squared equals 12 minus 12r. Just distribute my terms out front here. It's quadratic, so I'm going to combine like terms. This is going to be 5r squared. I'm going to take that 12r and add it to both sides. It gives me 13r over on the left. I'll take that 12 and move it over as well. Okay. And just to serve, you could probably use the AC method here just to serve us in regards to use the quadratic formula a little bit. Let's use the quadratic formula here. So I'll say it should be r equal to the opposite of b plus or minus b squared minus 4ac all over 2a. So maybe the AC method does not work here. We'll see. So that's going to give me 169, what, plus 60, plus 120, 289. Over 10. Anybody know what 289 is?
My weight.
Triple it.
Why would you cripple my weight?
So you can get 289. 289. Square root of 289. Good job, Chuck. Negative 13 plus or minus 17 over 10. So now what that tells me right there, because the radical disappeared, right? The radical disappeared. This tells me that even though I use the quadratic formula, other techniques, and in this case the AC method, would have generated the correct answer. Does that make sense? Okay. So negative 13 plus 7, or sorry, negative 13 plus 17, it's 4/10, right? Or 2/5. If I go negative 13 minus 17, gives me negative 30. Divided by 10 is negative 3. So those are my two values for R. Now, all you got to do here is pay attention, because we had division in the original problem, right? So when I get answers, I have to make sure that when I plug them back in here, I don't get 0 in any of my denominators. The only numbers that would give me 0 are if R was 0 itself, right? Or if R was 1. Okay? And then 0 here. So neither of those answers are that, so we're good.
An interruption, but with all freshmen last names A through F, please report to the auditorium lobby for pictures. Again, that is all freshmen last names A through F. Thank you.
Okay, so I want to stop there with the homework. We will go over more of these tomorrow. And I've got it right now to turn off tomorrow, but let's have that turn off on Thursday. Not Thursday, Wednesday. Let's go Wednesday. Okay. We talk about it a little bit more tomorrow. There are some couple questions on there that are important. Okay, so I'm going to scroll down here, and it says, should say a bullet. Okay, but every single time that we take a projectile, okay, and when I say projectile, I'm talking anything that is launched, thrown, kicked, dropped, tossed, whatever, okay? So this marker, what path did it just take? That marker, what path did it just take? It's taking a curve, arc. What do you call it?
Direction.
Parabola. Okay? Travels via a parabola, right? Every single thing that you launch is going to do that. Okay? Now, who's in physics? Okay, so in physics at some point, you're going to talk about this. Okay, and you're not going to see this demonstration with this applet here, but you're going to see something like this. Okay, and you're going to work through what we call vertical and horizontal displacement. And you'll have angles of kind of a launch angle that you talk about. Okay, that will help you find then those horizontal and vertical displacement. But every single time that you launch, throw, kick, toss, whatever, an object, it is going to follow there we go. It is going to follow some type of parabolic course. Okay, so if I fire this, okay, you see that red ball tracing out a parabolic course, right? Okay, so now if I stop at some point, let me reset it and start over. So let's say I stop it right there. Okay? The ordered pair of that point, I know you can't really see because it's zoomed out so far, but on the x-axis, that point is at approximately 20. On the y-axis, that point is approximately like 27. So what we've said is we've moved 20 units, and I think it's in meters right now, so 20 meters away, horizontally away from the launch position, and 27 meters vertically away from the launch position. Does that make sense?
Yeah.
Okay. That is the idea of horizontal and vertical displacement. What we're going to talk about in this class is not launching with this angle of 60 degrees here. We're going to launch with an angle of 90 degrees. So if I launch this, look at what happens to that object. It goes straight up, and then it comes straight back down, right? So every question we talk about in here, that's what we're talking about, okay? Launching it straight up, and it's coming straight back down. If I do that and change my x-axis, okay? So now what I've got over here on this blue one is that my x-axis is my time axis, and my y-axis is how high that object is in the air. If I launch this, and I pause maybe right there. Okay, let me get a tool so I can draw on this. My computer is worthless. All right, so not let me draw, but right there, that point, okay, you see down the bottom it says 3.74 seconds, right? Okay, now the height there looks like it's about like 20, maybe 22-ish, 23-ish. That ordered pair would be 3.74 seconds, comma, 23 meters. Does that make sense? So every ordered pair on there is a time followed by a height. Okay? Every ordered pair over here in the yellow was an X distance followed by a Y distance. Does that make sense? So there's a difference here. Okay? Everything on this parabola right here is going to be found. Every single point on there is going to be found by using what we call a differential equation, which is a calculus concept. It's actually like Calc 3. So h of t, we're going to write as -1/2 g of t squared. Sounds like a fighter plane.
Should we be worried or not?
No. Toledo does, National Guard out Toledo does a lot of,
I was just scared.
like over the summer you hear it a lot around here, and around my house I heard it a lot this summer.
Do we need to write that down?
Yeah. So that right there is a differential equation that tells us the height of an object for a certain amount of time that it's been in the air. Okay? Now, we're going to simplify that a little bit. That G stands for acceleration due to gravity. Does anybody know what the acceleration due to gravity is?
9.8.
9.8 meters per second per second. Okay? So what that means to us then is that when we replace that with 9.8, we get h of t equal to negative 1/2 times 9.8, which is going to be negative 4.9 t squared. And then I'll have these things. We'll talk about these things are in a moment. Now that's if we're talking about meters. If I'm talking about feet, does anybody know what the acceleration due to gravity is in feet? A lot nicer using feet. This is why we use it a lot in our questions and our homework. It's 32 feet per second per second. So then the convenience of that is that it turns into negative 16 t squared plus v naught, or v sub naught t plus h sub naught. Sub naught. So sub referring to subscript, not referring to the number 0. Okay. But when I say v sub naught, v stands for initial velocity. Okay. So v sub naught is your initial velocity. It's basically your starting point for velocity. H sub naught is your starting point for height. So here's the question. Does a bullet fly straight up with initial velocity or initial speed of 800 feet per second? So that right there is your v sub naught. Okay? So when I go ahead and plug stuff in, I get h of t is equal to negative 16 t squared plus 800 t. It never tells me anything about height, right? It doesn't say I'm launching it from a 20-foot cliff or anything like that. So h sub naught is 0. So there's no initial height here other than 0. Okay? So now the question is, when does the bullet fall back down to the ground? When does it fall back to the ground? Well, think about your x and y axes. If my x and y axes look like, I was going to do first quadrant here. That's stupid. If I just do the first quadrant, isn't my bullet on the ground at time 0? Okay, so remember this is h of t and this is t. Right there at time 0, I'm on the ground. When will I hit the ground again? Well, what does it mean for the height when I hit the ground? What is h of t? My parabola is going to take this course. Yeah. When I come back down and hit that spot right there, that height is 0. So doesn't that mean that can be 0 right there? I think 0 is equal to negative 16 t squared plus 800 t. I'm going to factor that. Should give me 50. So then I get 0 is equal to negative 16t, and 0 is equal to t minus 50. Here it's telling me t is 0, which correlates to that point right there. This is telling me t is 50, which correlates to the point in which or the time in which it comes back down to the ground. Does that make sense? So when they say hits the ground or returns to the ground, they're implying a height of 0. So you plug 0 in for h of t, and you solve. Okay? Now the next question is, when will it reach a height of 6,400? What am I going to do? Oh, not that one. What am I going to do with that one there when it asks when the time in which the height is 6,400? Yeah, take the h of t out and put 6,400 in its place and solve that quadratic equation. Is it okay?
What are we doing?
What if they ask us, when does this thing reach its maximum? When does it reach its maximum height? What time would it be that it reaches its maximum height? 25. Its vertex is always halfway in between. Always halfway in between the two x-intercepts. Okay? We'll pick up, so I'm going to extend that homework. There's another assignment on top of it, 5 more questions, 5 more story problems. And I'll push them both back. So keep working on them. We'll talk about them more tomorrow. Yes. So 800 divided by 16 is 50.
Why are you ignoring me? It's fed.
What?
Let me come up here and walk that down.
That's fine.